All right, who's out there? Do you have any questions? Oh, man. Woke up from an epic nap like 30 minutes ago. Feel my hair. Like I have like all of geometry. Kenya, really? All of geometry? The parallel lines? Tell me which one you want me to work. I'm not working all of them. What's up, Jed? So, trying to figure out parallel lines cut by transversal. So I'm going to explain it, and then I'll work one or two examples so you kind of get the idea. Okay. So if we have parallel lines, so we have two lines here, we say are parallel. Okay. So these lines are parallel. So I'm going to put a little tick mark right in the middle of them, just kind of show they're parallel. And then I'm going to cut them with the transversal, something like this. So I have two lines that are parallel, and it's cut by a transversal. This part's the transversal. These are your parallel lines. And then we have angles 1, 2, 3, 4. Let's call this 5, 6, 7, and 8. Now we did this I think last semester, where we talked about which angles are congruent and which angles are supplementary, and we used that idea to actually set up algebra equations. Well, in this case, if you remember that we use that wiki stick, we kind of put that wiki stick down like this, and then we would take our hands and we would put our fingers on that wiki stick, and if they felt the same, they were congruent. So in this case, angle 1 is congruent to angle 4, is congruent to angle 5, is congruent to angle 8. That just simply means that they're all the exact same measurement. So if this was 18, then this has to be 18, and this has to be 18, and this has to be 18. Well, what that then also tells me is that the other angles, 2, 3, 6, and 7, are also congruent. So angles 2 is congruent to angle 3. That's a horrible 3. Is congruent to angle 5. Angle 6, which is congruent to angle 7. Now, congruent leads to an equal sign. So if we said that if angle 1 was x, and this was, let's call this 71 degrees. And I wanted to solve for x. Let's say, change this to 72, and let's call this 2x. Say I wanted to solve for x. In this case, we see that it's in position for angle 1 and angle 2, or we have this little line going through it because these are vertical angles. We can actually say, well, since angle 1 and angle 4 are congruent, we actually say angle 1 here is congruent to angle 4. So we replace it. Angle 1 was 2x. And that's going to equal, congruent changes to equal is 72. Divide by 2 on both sides, and x equals 36. That's how you deal with things that are congruent. Now, if they're supplementary, that means we add them to be 180 degrees. In this case, any two angles that are not congruent are supplementary. So angle 1 and angle 2 are supplementary. Angle 1 and angle 3 are supplementary. Angle 1 and angle 6. Angle 1 and angle 7. Angle 4 and angle 2. See how this works out. So that means they have to equal 180. So that's the basic idea of everything I'm asking you to do. Okay, so let's work at one or two of these examples. So that's the basic idea. All right, so let's just start off with, let's say number 3. So number 3 has kind of got the same setup I have here. They tell you that this is 5x, and they say this is 115. Okay, so we want to see, are these angles going to be congruent, or are they going to be supplementary? If you want to number them, then just number them, it's fine. But I always just kind of think of that wiki stick trick I showed y'all. To go like this, it's kind of like an angled Z. With that, I can see that they are not on the line. Since they're both not on the line, we know they're going to be congruent. If one was on the line and one was not on the line, they'd be supplementary. That means that these angles have to equal each other. So all I do is do 5x equals 115, divide by 5 on both sides, and we get x equals 23, and that's it. So that's how you actually work that one. This is for geometry, so I have kids from 9th, 10th, 11th, and 12th in geometry, Jad. So some are not much older than you, and then some are considerably older than you. Did you guys already do this? Alright, so let's look at another one. So let's look at number 8. Because really what this pack is asking is basically solve for x to tell us what if it's parallel or not. So let's look at number 8. Number 8, we have something that looks like a trapezoid. Okay. Now, it tells me my equation that this angle right here is 3x plus 8. And this one is 6x plus 1. It tells you that this is C and this is D. Okay. Okay, so properties of a trapezoid. The reason why I'm bringing up a trapezoid is because you have exactly one side of, or one set of opposite sides that are parallel. Well, C and D are opposite sides, and we're looking to see if it's parallel. So we're really seeing what angles are going to make this a trapezoid. So if I assume that these are parallel, I can extend these lines out and get it out of this shape so you can see what's going on. Then if I erase this back half, it turns into basically the exact same problem that we had. So if I erase this and I extend these lines out, it's the exact same type of problem we had. Alright, so now it looks basically like the same setup that we've been doing. So you could do the line with this kind of this weird Z, like so. And we can see that one is on the line and one is not. That means they're going to be supplementary. So because they're supplementary, that means if we add them up, it's going to equal 180 degrees. So that's what I do. I just do 6x plus 1 plus, so there's my first angle. Here's my second angle, 3x plus 8. That has to equal 180 degrees. From there, we just simply solve for x. We're going to combine like terms, which gives me 9x plus 9 equals 180. I'm going to divide. I'm going to do algebra a little differently. I'm going to divide everything by 9. So I have a 9, 9, and 9 goes into that. So I get x plus 1 equals 20. And then just subtract 1 from both sides, and I got x equals 19. Done. So that's all that there are. That's all I'm asking you to do on these, is basically figure out, am I going to add them up to be 180, or am I going to set them equal to each other? 46. Yeah, these are questions from packets that I'm having my students do this week in geometry. So, what other questions, folks? So Fred, I hope that helps you. Yes. Wow. Code is here. Just saw it pop up on my stream that code is here. He still insists on spelling it with the C. Yeah. What are the questions? What are the questions? By doing... So, you want to be able to do this little trick here, which makes this little funky Z. If everything is on the same line, or if it's not on the same line, they equal each other. If one is on the line, one is off the line, then it's supplementary. You could just memorize the names of these. That right here, if we need to call this angle 1, angle 2, angle 3, and angle 4. Angle 1 and angle 2 are vertical angles. Angle 3 and angle 4 are vertical angles. Angle 1 and angle 3 are same side alternate angles. Angle 2 and angle 4, same side alternate angles. Those are congruent. Same side, opposite side interior angles are congruent. And alternate exterior angles are congruent. You can memorize all those, or just this little trick by doing the line, kind of like a snake going through it, or a Z. If they're not vertical angles, or if they're not alternating, as you kind of see they're alternating across, they're jumping across the line, then they're going to equal 180. If they are on this same line, they're going to be equal to each other, or if they're not on the same line, they'll be equal to each other. So if I say this is 5, 6, 7, and 8, 5, 6, 7, and 8 would all be equal. 1, 2, 3, and 4 would all be equal. 1 and 5 would have to add up to be 180, because you can see 1 and 5 are linear combinations, or a linear pair. 1 and 6, same thing, would have to equal 180. 2 and 6 would have to equal 180. 2 and 5 equal 180. It's just practice. I don't know how else to explain this over the internet, because this is one of those things where I gave you a hands-on thing to do, where you would put a wiki stick like this and you would touch it and not touch it. If they didn't feel the same, then they would equal 1. You'd have to add them up to equal 180. But if you touched them and they felt the same, then they would be congruent, because the feeling was the same. What else? What else? Huh? What do you mean, like half of it? This is one of those things where I taught it with the hands-on thing. Yeah, but it's abstract. I'm thinking. Try this. So if we have this, right? Instead of looking to find the things that are equal, find things that equal 180. And then if they don't equal 180, then see what it skips. You have to be able to do the whole thing, because right here would equal 180, right here would equal 180, right here, then right here would equal 180, here would equal 180. That might work. That might work. An idea. That might work. All right, let's try this. We have the same setup. It's important that you can go from this line to this line. These lines are parallel. Look on anything that's on a straight line. If I draw something straight here, 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 and here. If I number these 1, 2, 3, 4, 5, 6, 7, 8. All right, let's look. 1 and 3 are on the same line. So angle 1 plus angle 3 equals 180 degrees. Angle 3 and angle 5 are on the same line. Equals 180 degrees. Angle 5 and angle 7 are on the same line. 180 degrees. So I just do a straight line through 1 and 3. See, but then you know what? I can't do that because 1 and 5 are not equal to 180. They have to be consecutive on the same line. Let's say that. They have to be consecutive next to each other, except for the fact that 1 and 7 would equal 180. Nope, that doesn't work either. Yeah, the best bet, Fred, is just get used to drawing that Z like that. Kind of like a angle Z to actually figure it out. This is one of those things where I really need to be right there with you physically, having you point to things. I don't know, young lady. Really trying to think of how to do this. Because it's really easy to teach when it's in class. Trying to do it over the internet's tough. We can do this. As long as they don't skip, they equal 180. And the outsides equal 180. Yeah, just think of it that way then. So 1 and 7. So if it's not alternate, if it's just like 1 and 7, then they would be congruent as well. So like angle 1 plus angle 7 equals 180. And then same thing here. 2, 4, 6, 8, 4, 6, and 2, 8. And then 1, 2, 3, 4, 5, 6, 7, 8. They all equal 180. And then from there, 1 and 7, which I had, 2 and 8, which I had. That might be the best way to do it. Is just draw straight lines and use their rule as long as they don't skip 1. If they skip 2, if they skip more than 1, or if they don't skip, they equal 180. Okay. All right. She said it makes sense now. The traditional way of teaching is having them just memorize all the congruent and supplemental pairs. You're welcome, Fred. What other questions? Huh? Okay. So 15, we actually have 3 parallel lines. And then it's cut by a transversal kind of this way. Then we have 70 degrees, 70 degrees, and 110 degrees. And they want to know, they say this is line A, line B, and line C. And they want to know if these lines are, which set of these lines are parallel, if not all of them. So I'm going to look and see, okay. So I have 70 here. So directly across this has to be 70. Now if I stagger it out, that has to be 70. So because it follows this pattern here, we know that A is parallel to B because these alternate like this. Now, if I keep this pattern going down, I've got 70 degrees here because I'm skipping across the line. I'm going to skip across the line again and 70 degrees here. Well, that looks okay. Now, the only other thing I have to check is 110 plus 70, 180, which it is. So then we also know that B is parallel to C. Therefore, by using the transitive property in algebra, we know that A is parallel also to C. So these three lines are all parallel to each other. Just by alternating the angle all the way down, you would be able to see if they're parallel or not, because you can see 110 and 70, they match up to be supplementary. All right, what else? Yeah, 10 through 15, they're just asking what's parallel, what's not parallel. I'd go ahead and skip number 10 because they didn't label it. I didn't write this packet. I just pulled it from a workbook. There's no way to label it. And then the first half, 1 through 9, are the algebra problems. Anybody else? What other questions y'all got? Would have literally walked in here to change his sleep location. Funny. You have not been sleeping right. So 66 bags. Oh, they're so lucky. Yeah, I don't think there's any more questions. Number 9. Add them together. So we have this weird looking thing again. All right. So looking at this, we're looking for things that are parallel. They say this is C and D. Looks like it's going to be a trapezoid again, so we can assume it's a trapezoid. You can extend your lines out. See what's parallel and what's not parallel. We'll call these parallel. So this is going to be 6x plus 6. This one also be 6x plus 6. Also a square, which makes 90 degrees, right? That little boop right there makes it 90 degrees. So both of these have to be 90 degrees. So we just set the equation up. 6x plus 6 equals plus 90. Why did that doesn't go there? It goes here. Because it alternates. So this is 90, and this has to add up. If you remember, they have to add up to be 90 degrees. So plus 90 equals 180. So I'm just going to subtract 90 first from both sides. I got 6x plus 6 equals 90. I knew it had to equal 90 because these have to be 180 degrees. So just subtract it out. Subtract your 6. I've got 6x equals 84. Divide by 6. X equals 1. That's going to be a fraction. Write it out. 84 over 6. It reduces. Take a 2 out. No, it actually goes in evenly. 1, 24, 6, 14. X equals 14. Cool beans. Got to write my start time. It took about a minute. Hey. Took about a minute. Well, he retracted his eye. And I picked up some more packets today, and I'll be updating grades because we're pulling grades on Friday, so I'll have all the grades updated for everything I've gotten in by Friday. I'll do that tomorrow. Man, I'm tired too. I could lay right back down. Oh, Dad's on a different platform. I think his phone died. Good thing, honestly, right now, having hair in your food is the least of your worries. Just take it out and eat it. It's all good. Oh, she has to spell it out because her computer doesn't have emojis. My computer will do emojis. Wait, in the chat you can't do emojis? No, but hey, could you do emojis in the chat for YouTube? Uh-oh. As I was playing with it, it glitched. The internet was slow when I was trying to log on to YouTube earlier. What other questions? What other questions? What other questions? Oh, there it is. Comment emoji. Or sick emoji. There you go. Is that the sick emoji or vomit emoji? I think it's the sick one. Any math questions? Besides trying to figure out how to use emojis on your computer? What, a picture of a dog? Oh yeah, that is a boar. Gotcha. Wrong one. So yeah, I don't think anybody else got questions. There are 4 people on the stream. Coda's tired. He wants to go back to sleep. Yeah, I figured that. Oh. Man. 7th grader mocking a 10th grader. Is it not popped up on the chat yet? Oh, good. Questions, concerns, comments? Whether you're typing in comments. Questions. Chad, do you have any questions? You're just here to hang out? All right, well, let's see. Number 14. C, D, F, E. C, D is not parallel. C, D, F, E. So yeah, C, D is parallel to F, E. D, E is not parallel to C, F, because if you look, those angles don't add up. The angle C and angle D do not add up to be 180 degrees. But if you look, angle D and angle E add up to be 180. That's why C, D, and F, E are parallel, but because angle D and angle C don't add up. So if they add up to 180, then sure, but other than that, no. You awake over there? No. Good time. Man, my alarm went off, and I thought, it's like, man, I don't know. I think I wanted to continue with my nap. I looked at my phone, and I already had a message asking if there was going to be a stream today. Yeah, if you have a geometry question, I will answer it. The artist flavored Greek yogurt. That's an interesting name. What? No. Is that what they asked? No, yeah, no. I'll do algebra 2 questions. Any math questions you have, I should be able to answer with the exception of statistics. I'm really rusty at statistics and beyond some pretty fundamental calculus because I'm rusty at it. So if you have questions, just ask. Artist flavored Greek. That is a long name. In fact, if you're not a student, you can actually send questions. You can take a picture of your work and email it over to the email that's scrolling on the bottom here. buzzingaboutmath@gmail.com. If you just take a picture of it and send it to me so I can look at it, then I'll be able to solve it. If it's not something from Copper's Cove. No, I agree. It's not hard. It's not hard at all to pronounce it. Oh, that's true. I'm hoping I'm even saying Jad right. Can't even say the last name. Not even want to attempt it. No idea. Questions, Kurt? Any questions, guys? Come on, come on, come on. Falling asleep here. Y'all put my dog to sleep. And my wife. Busier today than it was the last 2 days. Yeah, Five's watching. One of them's my wife because she's the moderator, so really only 4. Falling asleep over there already. Number 11, AB parallel to DE. Yes. Yes, they are. Good job, Fred. That was actually one of the harder ones to figure out. Do a lot of things right. Thrilling. Yeah, when I was talking with Tad earlier, most of our conversation was about video games. She's got 5 kids. He gets lost into a video game. She's by herself with those 5 kids. That's why. But then when he gets home, but you can see, like, when I get on that game, I'll lose time of reality. Like, all grips on reality. You awake? Like, every time I look over there. I do not play Fortnite. Do not. I've been working on Zelda Breath of the Wild. I think I'm like, what, 30 or 40 hours into it? Something like that. The topography on it's amazing. It's just the OBS. I need to get in here and clean up this computer. That's not a surprise. Did you just now figure this out? Yeah, I already knew that. He talked to us like, you ever played Minecraft? I'm like, nope. Nope, not at all. I can make Fred mad right now. You awake?
Yes.
Because I can say, Ma, can ya? Hates it when people says their name that way. I know. But people...
So,
oh, Dad's putting fighting words out there. Fortnite's for babies. No, you can show it. I got it. Gotcha. It's so funny when she says it too. Oh, these two. My goodness. Guys, you ain't got questions. I'm going to call this. My wife's falling asleep. Coda's asleep. I'm tired because I literally just woke up from a nap. Not a surprise, young lady. Now, did y'all actually try out? All right, so what do you want me to do with complex fractions? Add, subtract, multiply, divide, go from mixed numbers to complex? There's quite a bit you can do with them. Fred says I'm still working. There's a lot I can do with complex fractions. Just let me know a little bit more specific, because complex fractions is literally like... Oh, I gotcha. So I saw a funny little... It's funny that they say something about complex fractions, because I saw a little cartoon that had this. And this is the child. This is the dad. And there's a door right here. And it says... Or on how to divide them. We can do that. But the dad tells the child here, you can't go out being mixed up. It's funny. It was funny. Alright. Let's see. Before we got into spring break, we were learning dividing on how to divide them. Okay. So dividing complex fractions is no different than dividing non-complex fractions. It's just dividing fractions, period. So if we have something like 7/9, no, that's not a complex fraction. Let me just flip that over. So we have 9/7 divided by 21 over, let's say, give me a prime number. 9 is not prime, 9 is composite. 5 will work. Alright, so 9/7 divided by 21/5. Oh. So what you want to do with these is you just simply want to, there's a basic rule. We're going to keep the first fraction. We are going to change division to multiplication. I don't know why I decided to spell it out. To multiplication. And then we're going to take the reciprocal, which I cannot spell, so I abbreviate, the second fraction. What that means is that you are going to flip it upside down. All right, so we're going to keep my first fraction, 9 divided by 7, complex fraction. We're going to change division to multiplication. I use the dot instead of x because I'm used to having variables. And then we're going to flip this over. Since it's 21's on top, 21 will have to be on bottom. And since 5 is on bottom, 5 has to be on top. From here, we just multiply our fractions straight across. 9 times 5 is 45. 7 times 21 was at 147. And then we look to see if this reduces. On a glance, for sure, it's going to reduce by 3 because 4 plus 5 is 9, 8 and 12. So for sure, it reduces by 3. I think it's the only thing it has in common. So we take a 3 out. I've got 15 over, it's got to be 4, 12, 49. 15 over 49. Is that what you're thinking, the artist flavored Greek yogurt? Because dividing, to me, there's no difference between dividing a regular fraction or a complex fraction because it's the same algorithm. Complex fractions, as far as my understanding of complex fractions go, is just when your numerator is larger than your denominator. If you're doing mixed numbers, I always convert it to a complex fraction and do the math, but the only time I ever use mixed numbers is in baking. There's one other field that we use mixed numbers in. So what else?
Sorry. Local multiplication of 1 plus 1 divided by plus 1, and then divided by x.
Oh, I was thinking improper fraction. I got you with the complex fraction. Read it again to me. X minus x over x minus 1. Okay, so complex fractions like this, what I do to teach my kids is I tell them, get it out of the complex, like this, and write it as a regular division like you see with fractions. So I'd write that my top fraction, I'm going to simplify this. 1 plus 1 becomes 2 over x plus 1. And then I'm going to write my division, and I do x minus x, which is 0, over x minus 1. So this is equivalent to this. So this is equivalent to this. From there, do you go to school at Copper's Cove? Because here, you can't solve this. Because when I change, I want to keep my same first fraction, change from division to multiplication, exact same as fraction. Take the reciprocal, now I have x minus 1 divided by 0. This doesn't work. This, for algebra purposes, is undefined. For other classes later on, this is either positive or negative infinity, but this is undefined. You can't do this. April, stay with me. Do you have a specific question in mind? Because if a teacher gave you this one, that's concerning. Huh? I'm a sophomore in pre-algebra 2. Oof. So with complex fractions, all you're going to do is I teach my kids to rewrite this. This middle bar right here, is your division symbol. So you just move this forward, move this up, and then just treat it the same. Yeah, that wouldn't be pre-algebra. I mean, I guess it would be, but that's actually more algebra 2 right there. Pre-AP algebra 2. Oh, I thought I said pre-algebra. Pre-AP algebra 2. Do you have a specific question in mind? That one didn't work out. You just want me to make one up? Books on here. No, they didn't. It's slightly different. So they have 1 plus 1 over x plus 1 over x minus right, I'll get you in a second. 1 plus x plus 1 over x. The x minus x divided by x. minus x over x minus 1. This is how they wrote it. Is this what you're thinking, artist? Let me check Fred's real quick. So Fred, your equation would be 2x plus 8 plus 90 equals 180. 2x plus 8 equals 180. 2x equals 172. X equals 886. Yeah, good job. The one. Not understanding the way they wrote it. There's a lot of combinations. I can write this as a fraction. Good job, Fred.
Sorry, he doesn't have.
It's okay. We'll figure it out. I'm gonna go find a problem. I think I know what the type of problem you're talking about. So here's a nice pretty one. So if this is probably way more complex than what you're doing right now, but this will illustrate my point. So we're going to have a fraction of 2x plus 1 over x plus 5 times x minus 5 times x plus 5 over x minus 5. No, that's not going to work. That's just canceling. That cancels. That cancels. Those cancel. Yeah, that one's not going to work. Let's go to this college course, see what they have. Let's do this one. This one will illustrate it. All right, let's do this. 5 minus 1 over a all over a plus b. So here's a nice common complex problem. You awake over there, homie? So when you're working with complex fractions like this, the first thing you have to do is you have to get it a fraction over a fraction. So this 5 minus 1 over a, you have to deal with that first. So what I'm going to do is I'm going to subtract those, and I'm going to have to get a common denominator. So to get a common denominator, I'm going to multiply this 5 by a over a, which is 1. So over here, a side note, I'm going to do 5 minus 1 over a. This is really over 1. And the way I actually teach my kids to multiply to subtract their fractions is multiply your denominators. Well, 1 times a is a. Then we're going to multiply up. A times 5 is 5a. And multiply up here. 1 times 1 is 1 with my minus sign in between. So this top is my numerator once you subtract those fractions. So now I have 5a minus 1 over a all over a plus b. Now, this bar right here represents my division symbol. So we can do 5a minus 1 over a divided by a plus b. Now, anything that doesn't have a fraction, you can actually just make it all a fraction over 1. That's just a general rule you can do. It's just a normal math trick we do. From here, it's the same idea of keep, flip, and change. So I can have my 5a minus 1 over a. I keep my first fraction. Change division to multiplication. And we're going to take the reciprocal of this. So I'm going to get 1 over a plus b. All right, from here, all you need to do is multiply these fractions together. So I multiply straight across and I multiply straight across. Well, 1 times 5a minus 1 is 5a minus 1 all over, well, a times a plus b is a times a plus b. You can distribute this if you want. That's a fairly straightforward way to simplify a complex fraction. Let's see what other good examples they have. I think this is the type of one he was talking about right here. This is the one that I think you were talking about. It's probably a little bit more complex, but this is one of these classic problems that teachers love to torture their students with. Okay, so we have 9 minus 1 over y squared over 9 plus 6 over y plus 1 over y squared. I think this is kind of what you were trying to talk about. With this isn't terribly bad. We want to add and subtract my fractions first by creating a common denominator. When I do that, this will actually work out pretty nice. I can already see how it's going to work out. My common denominator here has got to be y squared. So when I subtract my fractions on the top, I'm going to get 9y squared minus 1 over y squared. When I add these fractions on the bottom, I'm going to get 9y squared plus 6y plus 1 over y squared. Now, that's just adding and subtracting fractions, creating a common denominator. That's something if you're rough with, if you struggle with, everybody does. You just need to practice it. Now, this middle bar right here represents division, so we can rewrite this as 9y squared minus 1 divided by y squared times, well, let's do divide by 9y squared plus 6y plus 1 over y squared. Now, we're going to keep my first fraction, 9y squared minus 1 over y squared. Change this to multiplication, and we're going to take the reciprocal of the second fraction, y squared over 9y squared plus 6y plus 1. All right, from here, I'm going to reduce to simplify. This y squared and this y squared, they both go to 1. This top part factors to 3y plus 1, 3y minus 1 over 1 over, let's see, this is 9. Side note, let's factor this, 9y squared plus 6y plus 1 gives me 9. That's going to be 3 and 3. So 9y squared plus 3y plus 3y plus 1. 3, this gives me 3y plus 1. Okay. So yeah, add your fractions. So just kind of keep working like this. So this factors to 3y plus 1, 3y plus 1. Should have known that. So this factors to 3y plus 1 times 3y plus 1. Now I'm going to look at my diagonals to cancel. This 3y plus 1 and this 3y plus 1 cancel out, goes to 1. So this basically becomes 3y minus 1 over 1 times 1 over 3y plus 1, which then gives me my answer of 3y minus 1 over 3y plus 1 when you multiply straight across. not a terribly bad problem. The key to these problems, especially this, because they look bad, but the key to these problems is being able to add your fractions. Once you add your fractions, this middle bar just becomes division, and it just becomes an exercise of rational functions. So adding fractions is the key to these problems. This is a classic type of problem that math teachers ask, just because you have to be able to add fractions, factor, simplify, you have to divide fractions. There's a lot of different concepts going on in this one problem. Hopefully that helps you out, Greek yogurt. What other questions? Hey, though, artist, the way that you would write this would be parenthesis 9 minus 1 over y. This is how you would do this. Yeah, I know, Jed. This is like the syntax you would actually type it into a computer, would be parenthesis 9 minus 1 divided by y caret squared here, divided by open parenthesis 9 plus 6 divided by y plus 1 divided by y caret squared. This is how you would actually type it in on a keyboard. Or if you had to put it in some sort of program from that aspect. This is this. I don't understand. Do I pay for my videos? I don't receive a penny off of these videos. Because you're yelling at me, that's why. That's why your caps lock's on. Your computer's yelling at me. I do this just because people need help. And because it's fun for me. It's turned into a hobby. No, I'm not a YouTube partner. I just do this to help people. Then I make the videos and post them to help my students during a regular school year. All right. What else, guys? What else? I think I want to call it. It's been an hour. The artist flavored Greek yogurt. First time I've seen you here. Thanks for stopping by. If you have more questions, just come by and ask. I do this Monday through Friday at 5 o'clock Central Standard Time here in the U.S. Jad's always here. Then we have other people pop in and out asking questions as well. All right, so I'm going to call this. I'm going to go play some Zelda and then get something to eat and go to sleep. All right, guys, I will see you tomorrow at 5 o'clock.